Lou from Cisco.
Thank you. All right. So I've been told that I have 25 minutes, and I plan to use these 25 minutes to show you that I am an idiot, number one. My wife would tell you that I don't need that much time to convince you of that. But maybe idiot is not the right word. I think I'm ignorant. It's probably the best concept. I look at you and I see plenty of young people, hacking in your computers, using open source tools, using H2O, R, and so on. And I think of me as an old timer. I've been doing data mining and statistics-related projects and work for 15 years, more or less, with very powerful, large, enterprise-grade tools, SaaS, enterprise miner, intelligent miner, for those of you that are old enough to remember that from IBM, embedded in DB2 and so on. So plenty of very, very different type of technology, right? Different type of business model. And I have a hard time to adopt and adapt to this new world of open source tools and so on. I was quite skeptical when I saw H2O and so on. And this is the story. The story that I want to tell you today is about can a large company that has a large deployment, we have probably one of the largest deployments of SaaS in the world. Can a business like ours adapt to and adopt tools like H2O successfully, right? Can we trust? Can we do a good job of that, right? So my name is Lou Carvalheira. I work for Cisco, and I am one of the many teams that Cisco has using data mining. There's plenty in marketing, and there's also very, very excellent work done by teams in supply chain and demand, excellent customer related systems and we use to the technology, we use to the challenge and so on. My team is composed of 20 people. We do plenty of things, and since 2007 we started creating this what we call the propensity to buy model factory, and it's been around for at least 8 years, and we have managed to establish mechanisms to understand the value of that. So how much extra additional business do we get because we're creating models and because we're deploying those models in real business processes, right, from marketing and sales. And since 2007, we accumulated $3 billion in additional bookings and additional revenue. Cisco is a $50 billion company a year, so it's a lot of money, but I believe that it's a substantial contribution that I think we somehow made to the results of my company. The group itself is quite large in terms of what we do, small in terms of number of people, but we have forecasting as a main problem as well, predictive modeling, which I lead. Customer evaluation, we have models that try to understand how much money each one of the companies that Cisco deals with or tries to sell to has to spend in equipment from Cisco. We also have forecasting and optimization. So different groups or different teams inside my group that does that. Our team is quite small, for this predictive modeling factory. It's quite small, and that's why it had to be done in a factory type of arrangement. The mission of the team is pretty clear, right? We want to change the course of the business from Cisco by relaying insights, relaying information, relaying the best way to prioritize our efforts, right? Always, even in a large company like Cisco, we have a limited amount of resources, and we have to apply them in the best possible place, right? So this is what we do. I want to show you what a propensity to buy model is, as we understand, and it's essentially a model that tries to understand what is the likelihood, is a statistical model, and what is the likelihood that a given company will buy a specific product from Cisco, right? And that in a given relatively short time, right? So a time frame. So we don't want to know if they will ever buy something from Cisco. We want to know next month or next quarter or something like that. Very, very short time, right? So that we can act on that information and change the way we do business with them. We use different types of information to create these models, right? But essentially we use firmware graphics on the companies, right? So Cisco is a business-to-business type of reality, right? So we sell to other companies, and sometimes with the help of partners, right? Partners of ours, not really Cisco sales teams, but other partners that sell our products. So we use firmware graphics information from the companies. We use also all the history of transactions that the companies have with us, right? So we all accumulated since, I don't know when, right, 2000 and something. We have to also understand that we know some people very well in these companies, and we collect this information and put that in the pool of data that we use to train our models. We also collect all these interactions that we have with them. So every time I send an email to someone, in a company, every time I invite them to a webinar or a seminar in person, or every time I send them a piece of literature, whatever, all these connections and interactions that we establish with the people that actually buy the products, is recorded and summarized for our models. We also keep customer satisfaction surveys. Everything goes into the pile of information that we have to create the model, to train the models, and finally, because we work with so many different countries, and adoption rate of equipment, network equipment is different in different countries. We use macroeconomic, information to help. All in all, you can imagine 2,000 different variables that we use and have to create models. Not all of them clearly are used by specific models, but you have it in the pool of training data. So the idea is to create a model. You're pretty familiar with that type of technology. This is a model. You probably don't see this very, very clearly, but this is not a real bulldozer. It's just a model of a bulldozer, right? And that's what a model is, right? Is a simplified representation of reality that you try to, as long as it's helpful, as long as it's useful, right, use it, right? And once we have new information, not the historical information, but new, the latest view of all these things, how large the companies are these days, right? How much, what was the latest purchase of an equipment from a given company. We take everything that happened very, very recently, and we now score, right? So the scores actually are, you're probably familiar with this, with the notion of having two stages for the models, right? The first stage of a given model, right, of a predictive model, tries to understand whether the company or your customer will buy something from you, right? So yes, Cisco sells routers. Will company ABC buy a router from Cisco? Yes. Okay, good. That's one part of the problem. The second part of the problem is, which is very important, is how much will they buy if in fact they do buy from us, right? That's the second stage of our models, and they go hand in hand, because it may not be so useful to know that Arno Corporation will buy a router from us, but we'll spend just $1,000, when Sri Corporation will, have a 70% chance of buying, but if Sri buys, is like $100,000 in routers, right? Very different. So where do you want to spend your time and effort and investments, right? Different situations altogether, and it is this combination of these two things, the score, the probability, and the value, right, that gives you the real prioritization indication that you want, the expected value of the purchase. So this is our timeline. I hope you have a feeling for what we want to do when we create this propensity to buy. And the timelines. You have to remember, Cisco is a B2B company. We don't sell books. We don't sell very quick, turnaround, short cycle type of products, right? Our products, if you buy routers from Cisco or switches or servers and so on, they're going to be good for quite a while, right? They're going to be replaced in 3 years, 2 years, 4 years. So we have this advantage. We can wait a little long. It's not like, if you miss a beat, we're screwed. It's not like that, right? But we have to try and understand as much of the products that we sell as possible. And so this is the cycles, right? So we use everything that we can from history, right? All the history that we collected, and then we apply the very latest version of things, right? The latest firmographics, the latest, do we know more people in that particular company that could change completely our probability of selling to them. And finally, we create the scores, right? We use the scores, we create the scores, and here's the point, right? We have to have some time between knowing that Arno Corporation will use or will buy from us, and there's a high likelihood that Arno Corporation will buy from us, but that is not enough. What do we do with that, right? Knowing that Arno wants a router, what is the best way to sell it to him, right? And what is the price, what type of discount I'm gonna give it, and so on. So there's a huge amount of time that is spent with the insight that we're trying to provide to customize actions, right? To customize selling actions, or how I sell, how I market to Arno Corporation, Sri Corporation, and every other business that we have. We have 160 million Arno corporations. We have in our database plenty of companies, right? We work with the DMB database of companies, and that is quite large. We score every single one of these corporations, right? And we want to be able to be complete. So why do we have to have a factory, right? A factory is needed for many reasons. We, at a certain point, have decided that we wanted to be very, very, very specific. We don't want to mix countries. We want to have one separate model for each one of these countries. More than that, I want to separate large companies that buy massively from smaller and medium companies that don't buy as much or as frequently, right? So I start to, kind of having many different cells of types of customers that we want to create a specific model for. And that problem kind of got smaller and smaller and smaller, right? And multiplied. So we end up with 60,000 different models that we would have to have. And then if you think about the technology market, what we're doing here in this area of the country, technology is so vibrant, is so dynamic. What we had as a model last quarter is probably not useful anymore. All the patterns of the buying behavior, what companies buy and what they buy for, change. What used to be something that only large companies bought, right, in terms of networking equipment, now smaller companies are buying. So it's constantly changing, so we have to adapt very quickly. And on top of that, we have different universes of companies. We have the internal universe of companies. We have the external universe of companies, DMB, and so on. So there's a lot of models, right? And on top, and you probably see this in your own business, right? New data comes every time. We are constantly improving the way we collect data about companies, and therefore we want to bring that to our models, right? To see if it improves things. So the reality is you want to scratch everything that you've done last quarter and start over, right? And that is quite hard, frankly. It needs speed and so on. But this is the real truth. I mean, we don't have enough people, right? We will never have enough people to do everything that we want, so we have to really maximize our effort, right? I mean, the data miners that we have, couldn't keep pace of all the needs. So we have imagined this big setup of models that we want to redo every time, right? Very well. This is the component. This is the series of items. This is quite common, right? I mean, you all follow in one way or another this type of process, right? You massively, well, maybe not so massively, but you probably prepare. When Arno prepares data for Kaggle, he goes through these steps, right? Prepares data, tries to find, nice features to help him predict whatever target he has. Trains the models, and once he's satisfied with that model, scored, new data and try to use it, right? We have something that we try to do every time, which is, it's not just enough to say, here's a model, here's the scores, we believe these companies will buy, right? This is not enough. We have to make sure that we put, in that type of data, enough mechanisms to control whether we're doing a good job or not, right? So every time we create a model and deploy these scores, we embed in this data, right, in this deployment, control groups. right? And there's different types of control groups, random, which is the very minimum, but we also use naive control groups, right? That would, for instance, give you what would a business person, say is a good way to prioritize, companies, right? A regular salesperson from Cisco, how would he prioritize that? Well, I would probably say visit first the largest companies because they will probably buy more, right? And this is a very common and frankly reasonable approach, right? And it's a mental naive model, a mental model that is naive in that sense, but that still works, right? So we want to make sure that we're doing better than that, right? So we're constantly embedding that and making sure that we evaluate at the end of the cycle whether our models are beating that, right? And you can also think of ways to bring challenging models, right? So you have a feeling that you have a better way to do another model, and you develop it, and you know what? Let me compare that with my previous models, and to see if it's in fact good. So it's a good way to improve your processes, right? You're quite familiar with that. Our environment that we have is quite complex, clearly, like plenty of your in our own reality. We have SaaS Enterprise Miner, we have Teradata, we have Tableau, and we use different tools for different purposes, right? The challenges that we have, though, is that our SaaS environment is very large. It's used by many people, many different groups, and it's quite busy, right? Every time you want to get juicy, results out of that, we're competing with plenty of people that sometimes are using it just to create more data, using running reports and so on, right? The enterprise guide type of, for those of you who are familiar with SaaS, and the sequence of models, there are so many models, so much data, right? That our cycles for 1/4 of models, it would take us almost like a month, right? If not more, right? Of creating models and so on. That is very, it's a lot of time because we need that time to plan the actions. We want to do something about this, right? We want to direct our resources towards the best possible, customers, and we need that time. Another thing that we have as a challenge is that we heard the discussion earlier in the morning about decision trees. They're good, right? I mean, they're quick. We can do it pretty well. And they're reasonable, reliable. They're not the best, right, in terms of, the best possible predictions, but they're good and they're quick. So we decided to do this propensity to buy model, a factory, exclusively on top of decision trees. But there's limits, and we know about them, right? So this is, finally, let me show you how is the model, right? So this is the assembly line for the propensity to buy factory. These are probably, you see here the pipelines, the Teradata pipelines you're looking at there. That's how we receive the data. You probably, that's how it used to be. You don't recognize that. You didn't look very, profoundly, very deeply under your own, problems. You probably recognize some of these challenges. So enter H2O, right? So how are we using H2O and to clean this stuff, right? I mean, to clean this process. Well, Nahum mentioned that. We have to use H2O where it really shines, right? It really shines in model training and scoring. So we're essentially putting together, or we did that, just to prove the point that this is, in fact, something that we can rely on. We put together a very small cluster, 4 nodes with 24 cores each. So you can think of, this is not that large. We have, memory, 128 gigabytes of memory in each one of these nodes. And you're going to see later on that there's advantages in having smaller, funny as it is, a smaller number of nodes in a cluster, right? For certain algorithms that we use in H2O, it may sometimes be a good idea, right? Leave more memory and smaller number of clusters, and I think Arno spoke of that. And we're also using R to kind of control. So this is a huge amount of models that we create, and we don't want to have to start stuff, okay, control enter, right? So we want to create all of our models in a big sequence of actions, right? That do everything that we need. So the other thing that we want to do is, which was a problem for us before, is that all of the models that we had took so long that we had to do sampling of the data, right? We would never build a model with more than 100 or 100 and something thousand observations, right? Because we needed so many of them, and it would take so long, right? But that is a problem in itself. You know, you're preventing, you're somehow, you know, fogging your ability to see, you know, different patterns, right? And this is the advantage that we saw when we brought H2O to help us, right, with the factory. We can now start seeing and using all the data that we have, or almost everything that we have, right, in terms of history, tens and 40 million observations per model, right? So we train that, you know, quickly in 40 million observations. It's not tremendously large, but it's not small either, right? I hope you realize that. We're using now different types of techniques. We're using GLM, we're using random forest, we're using GBM, and when we need, when we need a powerful algorithm to find and help us with a very hard problem, we're using deep learning as well, right? So we're bringing all of these things together, right? And sometimes we use them all, right? I mean, we run all these models, we make an ensemble of all these things, and we collect the best possible result from all these models, right? So we go through the trouble of training plenty of models, and sometimes you use just one, sometimes you use many, right? All of them, actually, right? Depending on the problem. The result is that what we used to do in almost like a month of work, right? And running things and so on, now we do it in 2 days. Essentially, right? So it's a lot of more models, a lot of more different techniques, a lot of more data, but we still are much, much quicker than before. So we're seeing this, right? Big advantage already. If we do that, clearly we allow ourselves more time to actually use the results of the models, right? And the scores. And on top of everything else, accuracy, right? So because of all these new data mining algorithms that we're using, we're being more accurate, right? Which is the perfect combination of things. This is the old way of doing things, and I hope, I give you that. I spoke about this already, but I hope I give you a sense of, we're training. It's so important to have, a quick deployment of the models, right? For again, people like in marketing and sales to use the scores, that we almost like had to build models ahead of time and leave them waiting. Right? And then when we have the new data, we quickly score and say, okay, here is the scores, right? We are changing that. We don't need to prepare things ahead of time. We're now train and score. Boom, right? The very same thing. It's almost like we're using one more quarter of data. We're closer to the reality of, to time, right? Time zero type of thing, right? We're using much more, we're doing this much quickly than before. This is how it is today, right? So every time we train and score, and that's it. We keep going. As you can see, they're much longer, right? Where we need to spend our time thinking, I know Arnold Corporation will buy routers from Cisco. How do I approach him? Is it, the likelihood is there. I can see that happening. But if I don't do anything, will he buy or will? So clearly not. We have to do something special, right? The scores and probabilities and so on are just indications of things. So a lot of time has to be reserved for the use of this information, right? I mean, the use of the scores and the values and everything else that we have. So here's very quickly the main flow of the processes that we have, right? We essentially define the environment, put together, very quickly, and that's another advantage, right? We take, put up the environment. Here it is, clean, fresh, beautiful. Put all the data, ingest all the data, right? And then define the many different predictors and target variables that we will have in a big, massive data set. And we have plenty of columns that, for one model, this is going to be the target. For the next model, this is going to be the target. For the next model, this is going to be the target. But the main predictors will remain there and available. And so we keep a big loop of, okay, next model. And a model is, what is the likelihood that someone will buy routers? The next one, switches. The next one, servers. The next, and finer and finer details in terms of products. We do GLM, keep it. Use training, data set to observe the result and understand the result of that particular model. Sometimes we do many different random forests, one very deep, but not that many trees, very deep, almost like, let me allow it to go too far almost, right? I mean, to maybe learn too much, right? And then we say, okay, well, let me try to a very fat random forest where many different trees, but shallow trees, right? Not as many levels down. And we compare those in the end. We also use GBM, right? And if the models, each one of these models have a minimal amount of accuracy, if you use the area under the curve that you remember seeing, we say, okay, this model is good. I will combine the results of these models when I score with the result of the other model that I also created that was good enough. And we ensemble the results of these models in an attempt to use the best of what each one of these models are trying to, manage to pick up from patterns, right? I mean, the patterns that the models picked up somehow, right? So at the very end, that's what we do. We put it together. We start the second stage, right? So we run the second stage of the model, which is essentially, a regression, but we use GBM for that. And different ones, again, different architectures or different types of GBM, so to say, if you think about it this way, and combine the results, right? So once we're done with that, we're back to the problem that we always had, which is, okay, how do we deploy? How do we put control groups and so on? But H2O is being used for the quickness of creating the exact same, exact things that we've been hearing so much about, the nice, quickie, speedy and very accurate, or much more accurate results that we've seen in the new, in the new algorithms. You had a question.
Yeah. So one question is, are you doing much parameter search as you're retraining your models? And then a second question is, as you're giving the forecast to salespeople, are you giving them any kind of reason codes, like why this is a good sales opportunity because of product X fits in what they have or something like that?
Right, so the first question was, do we do essentially grid search? And we do. If you do a lot of grid search, you will see that some combinations, right, are really useless, right? I mean, some combinations of parameters are really useless, right? So we have managed to understand, initially we did a grid, and then we realized, wait a second, it's just this and that we have to combine, right? So we're doing, and then we combine. We don't do the grid anymore. We explicitly specify the models, right? Because we learned that, ahead of time. The second question is what do we do with the scores and values and so on once we have them, right? Essentially, we don't explain things, right? I mean, and that's one of the reasons we've had success for long enough for people to trust the results. So they look at us and say, I want the model. I know it's better to use the models, right? Everybody has proven that, right, before and so on. So I don't have to explain why this company is so much more likely to buy something than this other company, right? The models identify that, and people got to that level, or the users in marketing and sales got to that level of understanding that says, frankly, I don't really have a lot of time to understand why. Just give me my priorities, right? I need to go there and try to sell. So we're past that point where people say, why are your models good? What are they identifying? We're past that point. They trust that type of capabilities, right? They trust data mining, they trust these types of things that we do, right? Of course, it would be a different type of problem if we had to explain, right? Our main objective is to predict. We don't care how, right? That's why deep learning sometimes is the technique. We don't want to explain why that company is better than the other one. We just want to know that, right? With sufficient confidence. So I hope I addressed your question. But so this is what we have, right? And again, okay, I know I'm running out of time. What have we observed, right? I mean, first of all, the factory is better, quicker. We try more, different algorithms. We use more data. We're more accurate. We have more time to do the things that the people in business, excel at, right? Figuring out a way to sell to Arno Corporation, right? I mean, Arno Corporation is really, really, really different from the other ones, right? In which sense? Well, we have to find a way to communicate all of that to them and so on, right? And ensembles are really, really, really powerful, right? I mean, that's what we've been hearing from many, many, many different people, and you can do that very easily, right, with H2O, right? The same amount of time, you can create an ensemble of predictions. And that's really, really powerful. What have we learned, right? Well, one of the things that I mentioned already, right? Memory is pretty nice, right? Having more memory is good. We don't have to have a gigantic cluster of many, many different nodes and so on. We have a sufficiently powerful node with lots and lots of memory, right? I mean, it will solve our problems, right? To tell you the truth, after I ran a model for one particular technology, or there's a likelihood that people will buy or companies will buy routers, I get rid of all, I do a H2O.rm to get rid of plenty of things that I don't need anymore, right? Because I'm going to start a new model. So minor little things like that will go a long way to the use of the memory that you have, right? So pretty nice. Although I love the GUI way that Amy showed us, and we saw many times throughout the conference, I don't use it. I'm too busy. We have this flow of process. There's so many things that I have to do. I use R, and I don't care about anything else. R is king, right, to control this flow of processes, right? So keep that in mind. And now, it's just a very, thank you, right, I mean, to H2O. These guys are fantastic. I mean, I've been probably mistreated, maybe not, but before, with very large companies that, have plenty of customers and very large deployments and so on. Finding solutions for problems that we see in their products, is not easy, right? I mean, it takes time for them to understand what we have as a problem. It takes even longer for them to come up with a fix. It's hard to implement a fix, right? But these guys here, I remember saying, I don't know how to do this, and I don't see. I think a couple months back, and I know I have to finish, but a couple months back, I have to say this. A couple months back, I needed to do imputation in my process and so on. I said, yeah, guys, where is the imputation and so on? A week later, there was a way to do imputation in H2O. I was like, how? So the cycles and the level of support, these guys are listening, right? Which is very, very different from the very large, vendors of this type of tools. So big thank you to H2O and the support team. Tremendous. Every time I send them an email saying, how do I do that? 2 seconds later, Arno, Spencer, Srini, Tom, would respond back with save my life. So pretty rely on them, right? I mean, that's the beauty of that, right? And again, I want to do more, right? I want to use H2O for other things that maybe I need to do quicker, right? I mean, and data preparation is one of those things, right? So again, we're doing, this is my closing slide, we're doing more. Cisco relies a lot on the type of things that we do. It's very successful, a lot of money saved, a lot of money, additional revenue was brought to Cisco with that. So tremendous improvement in terms of time, accuracy, and so on, right? I'm happy. That's the bottom line. I'm happy. I don't know how many times you can see this, can say this about, providers of products that you rely on, but I'm happy. I want to close with that. I think it's probably what I want you to remember. I'm happy.
Well, thank you, Lou. And thank you for not sampling.
All right. Thank you for not sampling.
There's a question over there. Just let me give you the microphone.
Please speak with a microphone. I'm hard of hearing.
Do you ever measure the results of your recommendations in the real world and then factor those back into your models?
If I have a recommendation?
Yeah, like you suggest following up on a certain account because it looks likely from your analysis that they would buy a large amount of Cisco equipment. and you do, and sales team does follow up, do you measure whether that worked or not?
Yeah, I'm not sure. Unfortunately, the monitors are going the other direction. But if I remember, if I understood what you're asking is, if I have a recommendation for us how to prove that H2O is actually a benefit to us, right? Well, there's plenty of different ways, right? By the way, we adopted H2O first when we had everything in parallel, right? We continued with our regular factory, right? And H2O is here. So we pretty much know what it takes to do it in the old way and what it takes to do it in the new way, right? We know, based on results from the past, we know how to compare predictions, right? So we pretty much know the accuracy of all of that, right? And my suggestion to you is to prove points in general, right? In general, this is has nothing to do with H2O, right? Make sure you somehow embed control groups in every deployment, right? And if you come to me today with Cisco, right, and you say, I'd love to use your P2B models, right, your propensity to buy models, I tell them, that's fine, you can, here it is, but you're signing a contract with me. You are, without knowing, deploying control groups. So some of the people that you will meet and think is a very high likelihood type of customer, maybe that guy is not, right? Is not a high likelihood. I had to put that guy there to prove the point that the model was right. So it is the failure of trying to sell to that customer that proves the point that my model is working. I put that guy there on top of the list to prove the point that the model is good. I literally smashed the Mercedes-Benz against the wall to prove that everybody survived, right? I had to do that. But you wanna use my scores? You wanna use my models? You have to understand that. And I clearly will not tell you ahead of time who the control groups, who belongs to the control groups, right? Otherwise you would be, hey, I know these models are much better than the regular thing. I will not, try to sell to them because sometimes our models are wrong or are not as good as we think. It is sometimes the selling machine that at Cisco is so powerful and so good that sell routers to, Arnold's grandmother, right, corporation. Because it's very good at selling things, right? So our models are not doing anything special. It's really our sales, processes and price and the products. The products sell itself, right? I mean, it's type of thing, right? So we have to be able to differentiate that. I'm not sure I addressed your question fully. If I didn't, I'm sorry.
You have one more question here?
And I have to find a way to listen to this.
Do you score, or doesn't it, like opportunity scoring or lead scoring? That's where the propensity score goes, and how accurately predict the date of does not show. And
Yeah,
is
so-
it how fast? Is it 3 months, 6 months, or is it
Good.
within
So the question, I will repeat. The question is, okay, I clearly said I want my predictions to have a limited amount of validity type of thing, right? They will expire after a certain amount of time, right? So what is that period? And again, I remind you of the cycles, right, of Cisco and the products that we do, right? I mean, so cars, if you just bought a car last week, you're not going to buy a new car in a couple of years, right? Cisco products are kind of like that. So the cycles are long, and we try to do the following. We do this big, process of creating all sorts of models for all different products, and we predict the next quarter. So we are now trying, imagine that we're now in Q1 FY15, we're predicting for Q2 FY15. And we want to do this very quickly because there's 1 month, 2 months for us to understand where are the companies that will buy our products, create marketing and selling activities, right? Put people there, invite people to seminars, right? Invest our money where those opportunities are. So it all clearly depends on your business, right? Your business may be completely different from Cisco, so you have to think about that, right? But it's very important that you leave a lag. That's a common mistake. when we do propensity to buy models and so on, we don't put a lag, between the data that we have or thinking about, time going that direction. You have data on the history, right? I mean, explaining things to you, right? Patterns and so on. And then you're trying to predict something that's going to happen in the future. You have to allow some time for you to act on this information. So you don't want to predict what's going to happen right after. You want to predict things that will happen after a lag of time, right? This is very important. If you don't do it, think about it, right? Any other questions?
Yes, we have one last question here.
If I
30 seconds, please, last
30
question.
seconds. The answer is yes. Thank you very much.
You said that you continuously update your models. So I want to know, what techniques, do you use to update your models based on incremental data?
So when I say I update my models, what I actually mean is I throw them away. I redo my models. Updating models is a bad word. It's a bad way to express it. I take the models that I have used last quarter, right, or last time, and I said, thank you very much. I completely forget about them, and I restart from scratch. And depending on your business, you don't have to do that, right? You don't have. Imagine credit score companies, right? They're not crazy. They wouldn't throw away. Their very business relies on having a stable algorithm, a stable model for credit scoring, right? So it's a very different paradigm, so a very different situation, right? In my case, we throw away, we don't update. Update is a figure of speaking, right? I mean, our speech, we are actually redoing the models, right? Bringing all the information, bring all the new, customers who bought very recently, and how are they, and why are they buying, right? And so on. So we forget about update, redo. We're crazy. We go through all of this. We like to suffer. It's pain, right? It's just pain. It's not. Since H2O came on board, not painful anymore. I'm happy.
That's great. Thank you very much, Lou.
Thanks for the patience.